Hi everyone, what's up? Welcome back to my tutorial channel. It's Daniel here, and today I'm going to show you how to construct the least squares regression line. So in this view, I'm going to first show you how to make the linear regression line and then how to use it for prediction and how to make interpretation. So let's start with the linear regression line, the least squares regression line. Example 1. A real estate agent wants to study the relationship between the size of a house and its selling price. The table below presents the size in square feet and the selling price in thousands of dollars for a sample of houses in a suburban Denver neighborhood. So this is the data set, and this is the scatter plot. Remember in the last video I showed you how to make the scatter plot. So in this lesson I'm just going to reuse it. And our question is it reasonable to construct a tree line that best summarizes the training of this dataset? You see that here the dataset on the scatter plot, you see the data point tend to cluster around a tree line that is goes up, right? So our question is how to sketch that line on the scatter plot. So we actually have many lines to sketch around these data points. So here, for example, we have these two lines, and we have to figure out which line is better. The way we compare between these two lines is we make the vertical distance between the data point to the line. For example, here you see that the vertical distance between this point, the lowest point to the line on the first picture is the first red vertical line. You see that? And continue to finish the other data points. And on the second picture, we do the same thing. We make the vertical distance between the data point to the line. And then we sum up the square of the distance. The reason why we have to square it is because the distance might be either positive or negative. So if we add up, the negative and the positive value might cancel out each other. So in order to compare the total of vertical distance, we have to square the difference and then add them up. So we determine exactly how well a line fits the data by squaring the vertical distance and adding them up. I repeat, here we have to square the vertical distances is because the vertical distances may be negative or positive. So if we just add them up without squaring, some positive and negative numbers might cancel out and give a very small error, which is incorrect. So we have to square the vertical distance to get rid of the negative numbers and then add them up. For this point, some student might question, why don't we take the absolute value of the vertical distance? Because the absolute value is also help get rid of the negative numbers. However, if we have the absolute value on the equation, it would give us a difficult time differentiating the function in the further study. So that is the reason why we don't take absolute value, but we take the squares of the vertical distances and then adding them up. And the line that fit best in the line for which the sum of square distances is as small as possible. The line is called the least square regression line. So after we square the vertical distances and adding them up, The line that gives the smallest answer is the best line, and it's called the least square regression line. And in general, here we have two variables. So the variable that we want to predict is called the outcome variable or response variable. And the variable that we are given is called the explanatory variable or the predictor variable. So here in this example, we want to predict the selling price of a house. So the selling price is the outcome or the response, and the size of the houses is the explanatory variable or the predictor variable. Alright, so that is how we define the least square regression line. Now we learn how to compute the line. So this is how we find the slope and the intercept of the least square regression line. Remember, the least square regression line is a straight line, so we should need the slope and the intercept in order to construct the line. So given the order pairs x, y, where the symbol means x bar and y bar, the symbol is the innovation xs and xy, and the symbol sign a. The correlation coefficient r is given by r is equal to 1 over n minus 1 summation x minus x bar over sx times y minus y bar over sy. This is from the last video. And the equation of the least square regression line for predicting y from x is y hat. Y hat here is the predicted value. Y hat is equal to b naught plus b1x. And here b naught is called the y-intercept and b1 is the slope. The slope here is defined by the formula b1 is equal to r times sy over sx, where r here is the correlation coefficient that we computed in the first formula, and sy is the symbol innovation of symbol y, and sx is the innovation symbol of x. And the y-intercept b naught is y bar subtract b1 times x bar. In the equation of the least square regression line, x represents the explanatory variable and y represents the outcomes. So let's look at this example. Use the data in the table to compute the least square regression line. So here we go back to the example of the selling price of the houses. And we have some summarized number here. X bar is 2891.25, Y bar is 447, SX is 269.49357, SY is 2968405, and the symbol sign N is equal to 8. And some formulas here. R is equal to 1 over n minus 1 summation of x minus x bar over sx times y minus y bar over sy. And y hat is the predicted value. Y is equal to b naught plus b1x. This is the linear regression line, the least square regression line. And b1 is r times sy over sx. b naught is y bar subtract b1 x bar. Since in the last video I already showed you how to find the correlation coefficient, so in this video I'm not going to show you how to do it again. So here I just have to show you the answer. Here R here is 0.9005918. If you don't remember how to find this number, please check my video of the section 11.1 correlation coefficient and scatter plot. Alright, so now we already have the correlation coefficient. We use the correlation coefficient here to find the slope of the linear regression line. B1 is equal to R times SY over SX. R here is 0.9005918. SY is 29.68405. and Sx is 269.49357, and the answer is 0.09919796. And B naught is y bar subtract B1 times x bar. Y bar here is 447.0. The slope here is 0.09919796, and x bar is 2891.25, and the final answer is 160.1939. The equation of the least squares regression line is y hat is equal to 160.1939 plus 0.0992x. Use the linear regression line for prediction. So use a linear regression line computed in example 2 to predict the selling price of the house of size 2800 square feet. So here remember the equation of the least square regression line of example 2 is y hat is equal to 160.1939 plus 0.0992x. Here y hat represents for the predicted value of the selling price, and x is the size of the houses. Our interest is to predict the selling price of the house of a size 2800 square feet. That means given x is equal to 2800, how do we find y hat? Basically, we just have to substitute 2800 for x. So we substitute in 2800 for x, use y hat is equal to 160.1939 plus 0.0992 times 2800, and it is around 438.0. And don't forget the units of the selling price is $1,000. So we predict that the selling price of the house will be $438,000 or $438,000 in notation of dollars. So we guess that a house of the size 2800 square feet should cost around $438,000. And finally, how to interpret the least square regression line. Here remember the equation of the least square regression line is y hat is equal to b naught plus b1x. So we have three interpretations here. The first one is at y hat, how to interpret the predicted value y hat. So to interpret the predicted value y hat, we just have to substitute the value of x into the linear regression line to make interpretation for y hat. For in example 3, we predict that the selling price of the house will be $438,000, and this is for this house of the size 2800. The second interpretation is the y-intercept b naught, and this interpretation is only applicable when the data contain both positive and negative value of x. The y-intercept is where the line crosses the y-axis. So the y-intercept here is the estimated outcome when the value of the explanatory variable is 0. And the last interpretation is the slope b1. If the values of the explanatory variable for two individuals differ by 1, their predicted values will be differed by b1. If the value of the explanatory variable differ by an amount d, then their predicted values will be differed by b1 times d. So we have three interpretations based on the least square regression line. So that's it. Thanks so much for watching my video. Hope to see you guys on the next video. Bye bye.